My name is Dan Watson. I'm the interim department head in computer science here at Utah State University. I've been working with a team of students on a submarine submersible project in which the students design an autonomous vehicle that is designed to dive underwater and go through an obstacle course. We compete with other teams from across the nation. I was approached by a couple of my PhD students that had a project that they put together on their own, in which they ran a small submarine and put a processor on.
In order to make it easier to get to the stuff we made, so there was a tray that you could slide out. The problem is we kept, when we slide it in, then it would sever all of the wires.
We've got hardware for just about all of the tasks that are part of the competition. Some of the software we're still working on, but we've got a vehicle that actually can do them.
There are these waterproof pelican cases. Some of them range from only having one connection. This is a battery box, has a waterproof connection that just connects the power, whereas we have a motor controller box that has, I think, about 10 waterproof connections on it.
In our computer box we have the computer, we have some USB hubs for all the components. We have an IMU where we get attitude information like yaw, pitch, roll.
Finding all that equipment and putting it together was fun and it was interesting, but it was only the beginning of the technical challenge, because once you have all those components together, once you have everything that you need to get the submarine to work, you still have to give enough intelligence to that device so that it will do things in a way that make it seem almost magical. We have a mode where we can have a laptop running with a joystick attached to it and have someone actually physically running the device, but during the competition all that will be off. So the submarine has a set of tasks that it has to perform, and it's pretty much on its own to see how well it'll do.
I've developed a console that we connect to the submarine while it's in the water, which allows us to read all the sensor readings, the temperatures, pull camera feeds from our cameras on the submarine and display those on a laptop.
It's a really difficult problem for computers to recognize objects, especially in the low light of the pool where everything turns blue. To do the image analysis, we first we'll decide if we're looking for like a green buoy, for instance. We will look for all the pixels within a certain range of green. And then once we find those, we will do a blob detection, and we'll look for the largest contiguous regions that matched. And from there we can use those regions and squeeze them into like a circle, for instance, so we can see where's the center and what's the radius of the buoy that we're looking for.
The overall winners of the competition, there is a cash prize for some of them, but the cash prize is really less than the overall budget for the submarine. It costs more to win this competition than you could possibly win on the prize. It's more about, well, in some aspects, it's about bragging rights. You know, can you put together a team that's going to be able to compete? But I think it's more than that. For our university, Utah State University, this is an opportunity for us to show that our students can compete on a national level and do so with grace and style. And one of the things that is most exciting about our participation in this competition so far is that we're able to see that we can do that. We can compete at that level. And it's something that's just simply a natural extension of the educational program that we have here.